Welcome. Here's an application problem about zombies going for a walk. We have two zombies. One leaves and walks north at a rate of 3 miles per hour. And then after an hour, the other one starts walking west at a rate of 2 miles per hour. The question is, after 5 hours from the first zombie's departure, how far apart will they be? So we're assuming that the two zombies start in exactly the same spot. We have the directions north and west, which kind of leads you into thinking about a right angle. So we probably have a right triangle situation happening here. The twist with this problem is these rates. One zombie walks faster than the other, and one leaves before the other. So we have a little bit of further analysis to do with a problem like this. A diagram is still really helpful. Let's make a starting spot for the zombies. Just put a dot in for that. And one leaves and walks north. So north on our papers is usually upward, but I will label it capital N for north. The other one walks west. So from the starting point, heading to the left for west. And we need to figure out how far each of them has traveled. So the first one, the one walking north, that one travels 5 hours total. It travels 3 miles per hour for 5 hours. So the distance along the path for the northward zombie will be 3 hours times 5 miles each hour for 15 miles. So we have a vertical or a northward distance of 15 miles for the first zombie. The second zombie, walking west at 2 miles an hour, that one really only walks 4 hours because it had a 1 hour delay. So we have 4 hours times the 2 miles per hour rate that it walks at, and that means that that one will travel 8 miles. And if your diagram is like mine, it's not really to scale, but we do have a northward direction of 15 miles and a westward direction of or a northward distance of 15 miles and a westward distance of 8 miles. And once you have those two distances, then we can find the distance between the two zombies. And so in this diagram or in this scenario, the northward direction and the westward direction form the right angle. And so the distance that we're looking for is the hypotenuse of this right triangle. The Pythagorean theorem, a squared plus b squared equals c squared. We know both a and b, but we don't know c. Filling in the Pythagorean theorem, we'll get 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. 64 plus 225 is 289. That will equal c squared. And then we need to find c by itself. You can either take the 1/2 power of both sides of your equation or take the square root of both sides of the equation. You only need the positive solution to that because we're talking about distances. It seems like the square root of 289 is something really friendly. I'm checking on my calculator. Yeah, it's 17. So the square root of 289 equals the square root of c squared. We get 17 is equal to c. In this case, 17 is the distance between the two zombies after 5 hours from the first one's departure, and that means this is a measurement of 17 miles. Do put the label on your final answer. Let's check to see if it's reasonable. This hypotenuse length that we just found should be greater than either of the individual distances that we knew, and 17 is greater than either 8 or 15, so that's reasonable. And then 17 needs to be less than the sum of the two individual distances. If we do 15 plus 8, we get 23, and our distance of 17 is definitely less than that. So our answer here is reasonable.